What's going on, guys? So I decided to make a quick crash course on Terraform. And if you don't know what Terraform is, it's another one of those infrastructure as code tools. And so it's really great for modeling your cloud infrastructure through code. And so for anyone that actually wants to get more familiarized with Terraform or learn another automation tool, especially with regards to the cloud, this crash course is going to be really helpful for you guys. And I'm going to make sure to start from the absolute beginning. So I'm going to walk you through how to set up an AWS account. I'm going to walk you through how to set up and install Terraform. And that's going to be across all operating systems. So I'll show you guys how to install it on a Mac, on a Windows, and a Linux machine. I'll even show you how to set up a text editor like VS Code, which I highly recommend, by the way. And then, we'll get started learning the core concepts of Terraform and what it has to offer. I'll show you guys how to create resources on AWS within Terraform. We'll take a look at how to modify them, how to delete them. I'll go over how Terraform state works, and we'll take a look at how we can kind of reference other resources within our code. And I even have a mini project where we'll get to deploy a web server onto AWS. And it sounds simple, but there's a lot of things that actually have to happen from a Terraform perspective to get all of that to work. So I think that'll be a great learning tool. And I think after this course, or by the time you finish it, you guys would have a solid understanding of Terraform. And at that point, you guys can just kind of take it from there and then focus on specific topics that you want. And I plan to do a lot more Terraform videos. So if you guys have a specific topic you want me to cover, let me know, and I'll be happy to record a video and upload it to YouTube. But hopefully you guys enjoyed this course. And if you guys have any questions, just leave them in the comments, and I'll try my best to answer them. To set up an account with AWS, just navigate to aws.amazon.com. And here we can actually create an account and create a root user. So we want to click on this button right here that says create an AWS account. And it's going to ask for some basic information like an email address and a password. So just fill that in. And then you'll also have to provide in a account name. So I'm just going to call this Sloppy Networks. And go ahead and select your account type. You're probably just going to select personal if you're just making an account for yourself. But if you work for an enterprise, you may want to select professional. And it's going to ask for some basic information like your phone number, your country, your address, and you will need to provide all of this information. And to actually create an AWS account, you will actually have to provide your a credit or debit card information. Throughout all of these videos that I make, we're going to stay within the free tier, so you shouldn't be charged anything as long as you shut down all of your resources when you're done. And if you do end up getting charged, it'll be at most just a couple of cents. But AWS does require it, so you will need to have a credit card to kind of follow along with everything that I'm doing. And once you finish adding in your credit card information, it will ask you to verify your phone number. So it'll send you a voicemail or a text message, depending on what you select. So just wait for that text message to come in, and then you can just pass in whatever code they sent you. And we want to make sure that we select the free plan so we're not charged. Okay, and at that point, we should have an account set. you will receive an email address, probably just asking for you to actually confirm that you created that account. So we'll just go to my email. I'm gonna just select this, and then there should be. Oh, nope, it doesn't look like we need to actually confirm anything. So it looks like we're done. At this point, we can just select this button right here and just go and sign into the console. And so we're going to sign in as the root user at this point because that's all that's been created. And so we'll just specify the email address that we signed in with. And we're going to have to pass in the same password. All right, guys. So there you go. We've created an AWS account. So at this point, you should have access to all of the resources within AWS. You are logged in as a root user. So if you want to create other users, you can do that at that point. But most of my videos, I usually just log in as the root user just for simplicity's sake. To install Terraform on a Windows machine, there's a couple of steps that we have to perform. And the first step is to download the Terraform executable file. And so to do that, all we have to do is just do a quick Google search for Terraform. And we're going to select that first link. It's most likely going to be the first link, but if you want to navigate directly to their website, you can just go to www.terraform.io and then just select this downloads button right here. And here we can see all of the different operating systems that Terraform can run on. But since we're installing Windows, we're going to focus on that. So we want to select the 64-bit machine because that's what my machine is. However, if you're using 32-bit, select 32-bit. And this will download a zip folder. And so once that's complete, just right click and go into show in folder. So just navigate to your downloads folder or wherever you store your downloads. And this is a zip file, a folder. So we want to extract it. So I'll just right click, hit extract all, and it's going to pick a location. So this is the default location. I usually just leave that be. And so we'll hit extract. It'll pop up in a new window. We can just close that out. But you'll see that right next to that zip folder is the new folder that we extracted. And so I'm going to go into there. And you'll see that we just have one file in here. And that's just a single executable file that Terraform needs to run. And so what we're going to do is we're going to copy this file. And we're going to create a new Terraform directory where we're going to store this executable file. Now, where you create this Terraform directory does not matter. You can pick whatever location you feel most comfortable with. If you want to put it in my documents, that's fine. If you want to leave it in downloads, that's fine. The only thing that matters is you remember the exact location of where you're keeping this file. So what I'm going to do is I'm going to go to my PC. And I'm going to go into my C drive, and I'm just going to make a new folder here because that's where I want to keep it. And I'm just going to call this directory Terraform. Doesn't really matter what you call it. And I'm just going to paste in that executable file. Okay. And like I said before, the location doesn't matter. The only thing that matters is you remember this exact path to this file. And so to actually get this exact path, go up to this search bar right here. Well, actually, this is the search bar, whatever this is, and just click. And you'll see that it'll turn it into the exact, it'll transform it to the exact path. So I'm just going to highlight that, copy it. Okay. And now what we want to do is we want to set an environment variable that points to this path. So I'm just going to go to, whoops, not command. I want to go to env. So just search for those letters and there'll be a button that says edit the system environment variables. And then we want to select this button down here that says environment variables. Okay, and we want to focus on system variables. So we'll hit edit. Whoops. We actually want to select our specific environment variable. And the one we want to modify is path. Okay, so we'll hit edit. And so you'll see all of our environment variables for the path variable. And what I'm going to do is hit new. And I'm just going to paste in what I copied. So that path to that folder, hit OK, and then hit OK. We're done. Okay. And so if you have any terminal windows open, make sure you close it after you make that change. If you didn't have one open, then don't worry about that. And so now what we want to do is we want to type in CMD. We want to open up the command prompt. And I did not mean for that to be that big. And I'm just going to type in Terraform-V. Okay. And if you see this output, that means basically, this command is just going to tell you what version of Terraform you have installed. So right now I have version 12.26. You may see a different version if you download this in the future. The only thing that matters is that we see this output. So if you see anything else, that means there was an issue with your installation of Terraform. I recommend you just repeat the steps that I covered in this video. there really shouldn't be any issues that you run into. Just make sure that once you're done that you see this output, and that means you can now start running Terraform on a Windows machine. Now, there's a couple of different ways to install Terraform on a Mac machine. However, my favorite way is through using a tool called Homebrew. And if you aren't familiar with what Homebrew is, it's a package management tool for Mac OS. So it can be used to install all sorts of different packages, not just Terraform on your Mac. So I highly recommend that whether you choose to use this method or not, eventually install Homebrew. It'll make your life a whole lot easier. And so to actually install Homebrew, let's just do a Google search for it. And it should be the first link. So brew.sh is the link that you want to go to. And it's just going to give you this command right here to copy. So copy this command. And we need to go to our terminal now. So I'm going to go into Finder. I'm going to go into my applications and then just look for terminal. So I'm just going to do a quick search for that. Okay. And so this is what we want right here if you aren't familiar with the terminal. Okay, and so once the terminal's open, just copy and paste that line that you copied and then hit enter. And so this will automatically install Homebrew for us. You will have to provide your password. And then it'll just let you know that you need to hit return to continue. So just hit return. And this is going to take a little bit of time. So I'll pause this video for now and touch base with you guys once that's done. All right, now that Brew or Homebrew is installed, we can actually use Homebrew to install Terraform. And with Homebrew, we'll have access to a whole bunch of new commands, mainly the brew install command. So anytime you want to install a package using Homebrew, all you have to do is type in brew and then install, and then the name of the package that you want to install. So we want to install Terraform, so we can just do brew install Terraform, hit enter, and it's going to download the Terraform package for us and handle everything that we need. All right, now that the Terraform installation is complete, there's one last thing we need to do, and that's verify that the installation went okay without any issues. And to do that, all we have to do is just type in one command, and that's going to be Terraform-V. Okay, and it should, if the installation went okay, just print out whatever version that was installed. And so you can see that I am running version 12.26. However, if you're watching this video in the future, you'll probably see a different version, most likely a higher version number. But the only thing that matters is that you see the version getting printed out. If you see anything else, if you see an error, that means that the installation did not go as planned. And so you'll probably have to redo the steps that I covered in this video. But I don't think you should be running into any issues. It's a fairly straightforward process. Homebrew will set up everything for you, so you shouldn't run into any issues. To set up Terraform on a Linux machine, the first thing that we have to do is download the Terraform package. So we can just go to www.terraform.io. And on the Terraform homepage, we just want to navigate to that downloads button right here. So we'll select that. And on this page, just select the operating system that you're using. So we're using a 64-bit Linux machine. If you're using 32-bit, make sure you select 32-bit. If you're using FreeBSD, then just select the appropriate package. I'm going to select the 64-bit. I want to make sure I save the file and then hit OK. So at this point, it should be downloaded. So I can just, select this right here and it's going to take us to where we downloaded it. And it's a zip file, so we will have to extract it. And there's two different ways of extracting it. And I'll show you how to do it through the GUI, and I'll show you how to do it through the command line, depending on whichever method you prefer. So I want to extract this zip file that we just downloaded. So I can just select that and then hit extract. And then we'll hit extract again. And then it'll say extractions completed. And then we can select show the files. And it's going to show us in our downloads directory the original zip file as well as the unzipped Terraform file. So this is the file that we really care about. However, I want to show you guys how to do this through the command line because I think that's an important skill to have. So I'm just going to move to trash. Okay. And I'll show you how to do it through the command line. So we'll just go to our applications and search for terminal. And we want to navigate to where that zip folder is. And so I've set up my machine to download all files to the downloads directory. That's usually the default location. And so we'll do cd downloads. And if I do an ls, we should see the zip file. And I can just do unzip and then the name of the file. However, if you don't actually have the unzip utility, then you'll have to do a sudo, apt install unzip first so that you can get access to that utility. And then once you have access to that utility, you can just do an unzip and then Terraform. Okay. And you'll see that if you were following along on the GUI, you'll see that it did create the file for us, and we can verify with an ls. So we've got the original, we got the original zip folder as well as the Terraform executable file. Now we're almost done. However, there's one thing that we have to do is we want to move this to a location that'll allow us to run the Terraform command regardless of what directory we're in. Because right now we can only run it when we're in this exact directory, and it's kind of a pain to always have to move to our directory to be able to run Terraform commands. So what I want to do is, or what I want you guys to do is type in the command mv. So this is going to move a file to a specific location. And then we want to move the Terraform file, and we want to move it to /user/local/bin. Okay, and it's going to throw an error. It says permissions denied. So if you see that error, just run the same command except put in the word sudo beforehand. So this is going to give us root privilege, and you need root privilege to move any folder into this specific directory. So we'll hit enter. It's going to ask for our password. Okay, and so it looks like it's completed. So we'll just move to that directory and just verify that it did actually move it there. Okay, so it's in the user/local/bin directory. Now I want you to move back to your home directory, so you can do cd and then tilde. So that's going to take us to our home directory, or just move to any directory. If you want to move to the root directory, just move out of that folder. And now what I want you to do is type in the command terraform -v. Okay. And if you see this output, it should print out the version of Terraform that we downloaded. So I'm using version 12.26. However, if you're watching this video in the future, you're probably going to see a different version. That's perfectly okay. The only thing that I want to ensure is that you see some version get printed out. That means Terraform is installed and everything is working properly. However, if it spits out any other message, okay, if it shows you anything else like, Terraform's not a command or anything like that, that means there was an issue with your installation, and I recommend you just repeat all the steps that I performed, and hopefully that fixes any issues that you may run into. But at this point, you're good to go. You can start using Terraform, and so in the next videos we'll get started on actually playing around with Terraform. All right, guys. So there's one last step to setting up Terraform, and this is technically an optional step, but I highly recommend it. And so what we're going to do is we're going to install a very powerful text editor. Now, you can use any text editor of your choice. It's not going to make a difference. So if you prefer something like Sublime, feel free to use that. However, I'm going to be using one that's called Visual Studio Code. And so this is a free text editor that's provided by Microsoft. It's supported across all operating systems, and that includes Windows, Mac, Linux. And it really is one of the best text editors out there. There's a lot of people that use it, and I highly recommend you guys use this if you want to follow along with my videos, because I'm going to provide a lot of tips within VS Code that'll help make your life a little bit easier when you're trying to work with Terraform. So if you want to follow along and get VS Code as well, just go to code.visualstudio.com, and the website should automatically detect what operating system you're on. And so you should just be able to hit this button. So you can see here it detected I'm using Windows, but if you're on a Mac, it should say, download for Mac. So just download that. Moving forward, that's what I'm going to be using. But, once again, if you want to use something else, feel free to do that. But anyways, once you've got VS Code installed, I do recommend that you install an extension. So if you aren't familiar with extensions within VS Code just give you some extra functionality. So to actually see your extensions, once you open up VS Code, it looks like I already had it open, but you want to navigate to this button right here. So this is going to manage all of your extensions, and just search for Terraform. Okay. So once you search for Terraform, the first one should be the one that you want. But just to double check, make sure it's the one by HashiCorp, who's the company that makes Terraform, and just do an install. And so this extension is going to provide us a lot of features that make our life easier. So you can take a look at them, but obviously auto completion is great. Syntax highlighting, auto formatting, all of these are going to make your life a lot easier when you're writing Terraform code. But once you have that done, at this point, VS Code setup, that's all you really need to do. It's just going to behave like any other text editor, so you can create and delete and modify files within here. So it's kind of like an IDE, but we're going to use it for Terraform. Now that we've got Terraform installed and our environment for the most part set up, the last thing I want to do is just create a directory that we can store all of our code in. And so within my documents, I've created a folder called Terraform Project. And then within this folder, I've created a folder called Project One. So this is going to be where we're going to store our code for our first project. And so, feel free to make a directory wherever you want. If you want to keep it in downloads, if you want to keep it on your desktop, just pick a location. And once you have that location set, to actually open a folder in VS Code, we can just open up VS Code, go to File, go to Open Folder, and then navigate to wherever that folder is, select it, and then we can open it up. All right, and so at this point, it's going to give us a welcome page, which we don't care about. So just close it out, and you'll see that we've opened up Project One within our root directory, and there's no files or folders within there. Now, Terraform is written in a language called HashiCorp Configuration Language in a file that has a .tf extension. So all of our Terraform code is going to be stored in a file with a .tf extension. So what we're going to do is we're just going to do new file. If you right click here and just do new file, I'm just going to call this main.tf. And the .tf just signifies that this is a Terraform file. And you'll see a couple of pop-ups if you install the extension. Just ignore those for now. But keep in mind that you don't actually have to call this main. You can call this, file one. You can call it first project.tf. Just make sure it has a .tf extension. Now in this file, the first thing that you have to do is define a provider. And in Terraform, we have this concept of providers, which basically just allow us, or it's a plugin that allows us to talk to a specific set of APIs. And if you go to their documentation page, so if you just go to terraform.io/docs/providers/index.html, it's going to show a list of all of the providers that Terraform supports. So if we download, let's say the AWS provider, right? Where is it? AWS provider. That's going to make sure that Terraform downloads all of the necessary code to talk to the AWS API so that we can actually create resources within our AWS environment. But you can see that, Terraform, even though it's really synonymous with, cloud automation, you can see that it's got a ton of providers outside of the cloud space. It obviously does support, all the major cloud providers, as well as some of the smaller cloud providers. But it also supports Kubernetes. It supports VMware. It supports, like DigitalOcean, DNS. So it's got a lot of support for a lot of different platforms. Just keep in mind, though, anytime you want to work with any of these platforms in Terraform, you will have to install the necessary plugins so that we can talk to those providers. And you might be wondering, well, we downloaded Terraform, shouldn't that come with all the code to talk to all of these guys? Well, think about this, guys. For the most part, are you guys going to be working with all of these providers? No. Each customer or each user is going to have a predefined set of providers that they're going to work with. And there's no point in Terraform shipping out all of the code for all of these providers in the installation package. So instead, on a per user basis or per project basis, Terraform will figure out which plugins need to be installed based off of the provider configuration in your Terraform file. And so we want to use the AWS provider because that's what we're going to be working with. So let's just click this, and it's going to give us an example on how to actually set that up. And so you can see that this is the configuration for a provider, and hopefully this is big enough for you guys. I'll just do a control. Let me see if I can make this a little bigger. We'll zoom in 110%. I think that should be good enough for you guys. But yeah, this is all we really need. So we can just copy this. Actually, the version is optional. So we can just leave that out. I'll just do copy, and I'll just paste that in here. And I'm just going to delete the version. Now we're hard coding the region to be US East 1. And before I do that, I kind of want to explain exactly, what are regions. If you're new to AWS, basically a region is just a location where Amazon or AWS has a data center. And so there's a whole bunch of different regions. And we can actually take a look at all the different regions that Amazon has if we just search for AWS and log into our console. And so let's say my account, we want to go to AWS Management Console to log back in. And I'm going to be logging in as my root user. So we'll do okay. So this is our management console. And if you just select this button right here. So right now mine says Northern Virginia, but yours may say something else. You can see all of the different regions or data centers that that AWS has. And so it's going to default and use whichever data center is geographically closest to you. So I'm on the East Coast in the US, so it defaults to using the Northern Virginia data center, or what's referred to as US East 1. However, if you're in like California, it's going to default to probably US West 1. And so, what I would recommend that you guys do is that following along with me, I would recommend that you just use US East 1 like I am. It's going to help prevent any weird issues with like AMIs, because for some reason, like if you want to deploy an Ubuntu AMI in one region like US East 1 and one region in like US West 1, they'll have different names or IDs. I don't know why AWS decided to do that, but it can lead to issues, because if you're copying my code, the AMI instances might be called something else. So just set it to US East 1, and in AWS, or sorry, in Terraform, set it to US East 1. And so that way, my resources as well as your resources will get deployed in the same exact region, and we should hopefully avoid running into any weird issues. All right. And so now that we've got the provider set up, if we go back to the code, it's going to keep walking us through how to set things up. And so the next thing that we have to do is set up authentication. Now, authentication can be a bit tricky with Terraform. And what I'm going to do is I'm going to start off doing it the wrong way. Right? We're going to just hard code our static credentials into our Terraform file, which is not recommended, because obviously if you're storing your actual access keys within this Terraform file, if you decide to eventually publish your code onto, GitHub or something like that, well, then now all of your credentials are being stored in GitHub, and so that can be a security vulnerability. However, I want to start off doing it like that because, one, I want to show you guys how to do it every possible way, but also just to keep things simple for now. I promise we'll have some sections later on that covers how to do this in a more secure manner, but let's start off just by, doing the bare minimum so that we can focus on learning Terraform before we start worrying about security or anything like that. And so basically, all we have to do is get our access key and our secret key and pass it into the provider config. And so to do that, let's go back to our AWS Management Console, and you want to just select your profile name and then just go to My Security Credentials. And then here you want to select this access key tab, and you want to select Create New Access Key. Okay, and if you do Show Access Key, this is my access key, and this is my secret access key. So this is what I'm going to paste into Terraform. All right, so I'm going to copy this right here, paste it into my code, and then go back to here and then copy my access key, paste it into here. Whoops. All right, so we've got our access key set up in Terraform. Now, when you actually create security credentials within AWS, you can only see these values once. Okay, so once you see these, you won't be able to get them again. So make sure you store them in a safe place. You can actually hit this download key file, and it's going to download a CSV file with all of that information. So we can just click on that, and it'll by default open up in Excel. But you can see here, this is where my access keys are stored. So just keep that in mind, because once you hit close, if you try to look at your access keys, you'll see that we can see the key ID, but we can't see the secret key anywhere. And Amazon does that for security purposes. So make sure you write that down. However, if you lose it for some other reason, just delete your old one and then just create a new access key, and then you should be good to go. Okay, so now that we have our provider set up and our access keys set up, the next thing to do is let's try and figure out how we actually create or provision a resource within AWS. And within Terraform, the syntax is actually really simple. And this is probably one of the nicest parts of Terraform, and is really the main selling point of Terraform, is that regardless of what provider you're using, so whether you're trying to create a resource within AWS or a resource within Azure or GCP, it's going to use the same exact syntax from a Terraform side, so that you don't actually have to learn the underlying API from, Azure or AWS or GCP. And the main syntax is going to be, you type in the word resource, and then in quotations, you're going to first provide the provider name, right? And so in our case, we would pass in AWS. Then you do underscore, and then you do resource type, right? Whatever type of resource you're trying to deploy. And then you have to give it a name. And then we're going to do curly braces. And then within the curly braces, we provide in all of our config options. And these are going to be basic key value pairs. So key equals, and then, some value, right? And then key 2, that's going to equal, another value. So that's the basic structure of how to create resources within a provider. And so I'm just going to comment that out for now. And I'm going to walk you through how to deploy an EC2 instance within AWS. And if you don't know what EC2 instances are, it's basically just a virtual machine within AWS. So if you want a Windows server deployed in AWS, you're going to be doing it in EC2. But you can obviously deploy any type of machine that you want. If you want to deploy Linux, if you want to deploy a database, you can all do that within EC2. And so before we actually deploy that within Terraform, I want to kind of walk you through how to do it within the AWS console, because I think it's important to see, how to do it in the console and then how it kind of maps to in Terraform. But obviously, if you guys are already familiar with AWS and the console, this is going to be really trivial. So you may just want to fast forward the video. This is more from people that are also kind of learning about the cloud while also learning Terraform at the same time. And we can just go to our services tab at the top, select EC2, and then select instances. And you'll see that I have one instance terminated and one instance running. If you just created an account, you shouldn't see any instances. I'm actually going to just delete this for now. I'm just going to terminate that. And I'm going to just deploy a new instance. So I'm just going to hit launch instance. And here we've got all of the different AMIs that Amazon supports. So there's millions of different AMIs, and you can even create your own. However, I want to deploy just a simple Ubuntu AMI. Okay, and if you guys don't know what an AMI is, it's really just an image. Okay, so there's going to be an AMI for Ubuntu, there's going to be an AMI for Windows, there's going to be an AMI for Red Hat, one for Fedora. And I'm going to search for Ubuntu, and we're going to select the 18.04 LTS. And you can see here, this is the actual AMI ID that's associated with this Ubuntu server. So we can hit select. Here we specify the instance type, the EC2 instance type. And so, obviously there's different, sizes and speeds. So some have more CPU, some have more memory. So obviously if you want a really high performing server, you want to go down to one of the ones at the bottom. But obviously the more high powered they are, the more expensive they are. So for demonstration purposes and for just learning, stick to T2 Micro because it's part of the free tier. So you shouldn't be charged as long as you shut it down accordingly. So we'll just hit review and launch. And you'll get this page. We'll just launch that. And it's going to ask you to provide a key pair. For now, just ignore that. So we can just say proceed without creating a key pair. And we're going to launch that instance. And if we select this view instances button, that's going to take us back to the AWS console. And you can see that it's now creating this new instance. So it's in a pending state at the moment. But if you give it a few minutes, it'll eventually turn into, it'll get colored green, which means that it'll have been fully deployed. And then at that point, you can actually start using it. But that's how we create an a EC2 instance within AWS using the console. Let's go ahead and create it using Terraform now so that I can really show you how quick it is to do it through Terraform versus just using the console. And so like I said, the syntax is going to be just like this. So we're going to do resource. And then our provider is going to be AWS, right? It's just based off of what's provided here. Then we want to do underscore and then the resource type. And you might be wondering, well, what is the resource type? Well, this is something that you actually have to refer back to the documentation. So let's go to the documentation. I'm already on the AWS provider page, and we're just going to do a Control F for EC2. Just keep going down. Actually, that's not what I wanted. Here we go. We want to search EC2 on the left side. So just open that drop-down menu, and we can just unexpand data sources. We don't care about that. We care about the resources section. And so what we want to do is look for AWS underscore instance. So this is how we deploy an EC2 instance within AWS. And it's going to give you an example. And this is what I love about their documentation. Their examples are super helpful. But basically, ignore the data. Once again, we want to focus on just the resource. So this is pretty much like the bare minimum of what we need. We have to specify an AMI. Don't worry about this goofy syntax. He's using variables and things like that, which we're not going to cover yet. Instead, what we're going to do is we're going to hard code the AMI value in the instance type. For now, we'll ignore the tag. So I'm just going to copy this. I'm going to delete what I had started already. And so you'll see that, remember, the syntax is the provider underscore, and then the name of the resource type. So in this case, it's just instance. And then we have to give it a name. So this is a name that's not going to be, set in AWS. This is a name so that we can reference this resource within Terraform. So this name is just going to be scoped to just Terraform. It has AWS will not be aware of this name. So I'm just going to give this name of my first server, but you can call it whatever you want. Okay. And so the AMI, we're going to delete that. And to get the AMI, we're going to deploy another Ubuntu server, and we'll do a launch instance. And then if we search for that Ubuntu server again, we want to go here and just copy this AMI. And I recommend you follow these exact steps and not just copy what's on my screen, because Amazon has a tendency to kind of change up the AMI IDs. And so you may end up copying this one, which may get changed in the future. So, go to here, search for it, and then just grab the AMI. And we want to put it in quotations. So we just paste the AMI in there. And then the instance type, we want it to be T2 micro, just like we selected within the console. And we'll delete the tags. And before I actually run that code, let me go back to services and EC2, and let's just verify what we have running right now. So I've got 2 terminated and 1 running. So once this gets deployed, we should see 2 running. So make sure you save your configs. Now what we need to do is open up our terminal. And so, if you're on Windows, you can just hit the search button and just search for CMD to open up the command line, or, do whatever the necessary steps are for a Windows or a Mac. And then you want to navigate to wherever this project is. Okay. So for me, that's going to be in Documents. And then I think it's called Terraform. Not that one. Terraform-projects. And then if I do a dir, okay, so then we want to navigate to this project 1. And here we're going to run our Terraform commands. However, it's kind of a pain to have to open up the command line and then navigate to that folder. Instead, what you can do is, I'm going to move this off to the side for now. We can go to our VS Code, and this is why I absolutely love VS Code. We can go to New Terminal. And it's going to open up a terminal. And if it's a Windows machine, it's going to open up a Windows terminal. If you're on a Mac, it's going to open up a Mac terminal. If you're on Linux, it's going to open up a Linux terminal. And it's going to automatically take you to the project directory. So you can see it's already navigated to project 1, which is the root of our directory. And so here we can actually run our Terraform code instead of having to kind of flip back and forth between our code and this command line right here. So I'm just going to close this out because we don't need that. I'm just going to use VS Code moving forward. Okay, and the first Terraform command that you need to learn is Terraform init. Okay, and so what Terraform init is going to do is it's going to look at our config in all of our Terraform files, which are anything that starts with .tf, and it's going to look for all of the providers that we have defined. So right now we just have one provider, and so it's going to see that we just have provider AWS, and it's going to download the necessary plugins to interact with the AWS API. So let's do that. We'll do a Terraform init. And let's actually take a look at what the output is doing. So you can see here, it's initializing the backend, and it's now initializing the different provider plugins, and then it's downloading the plugin for AWS. If we decided to add in a separate provider, so if we did like provider and then maybe one for Azure, well then it would not only download the code for AWS, it would also download it for Azure. Okay, but you should see that Terraform is successfully initialized. If you see some other kind of error, then you may have to do a little bit of troubleshooting, but just make sure you see that nice shiny green output. Okay, and so we've got that set up. The next step we want to do is I want to show you the Terraform plan command. And the Terraform plan command, what this does is it kind of does a dry run of your code. So you can see all the changes that will take place. It'll kind of show you, if it's going to delete any instances, if it's going to create new instances, if it's going to modify instances. So it'll just do a dry run so that you can make sure that you're not accidentally about to break your production network or something like that. So I always highly recommend you run a Terraform plan, even though it is completely optional. It'll just be like a quick sanity check so that you can just gloss over the changes that'll be made and you can just make sure that you're not going to break anything. If you do Terraform plan, and this may take a little while depending on how much code you've written, but we just have one instance, so you should see that it should be a minimal output and it should be fairly quick. But if we kind of scroll up a bit and just take a look at what's happening, you'll see that it's going to color code things depending on the action. So if you see a plus, that means it's going to create a resource. If you see a minus, and it's usually colored red, I think, that means it's going to delete a resource. And then if you see something that's orange with a tilde, that means that it's going to modify a pre-existing resource. And so if we scroll down a bit, you'll see that right now we're going to be creating an AWS instance, an EC2 instance, and you'll see that we're using this AMI. And then you'll see a lot of details are not known at this point, so it'll be known only once we actually deploy it to AWS, because we won't know the ID that AWS gives it until we actually deploy it. So you'll see that most of these fields are unknown, but except for the ones that we've actually specified, like the instance type. Source dash check defaults to true. So some of the defaults will automatically get applied. But this is just letting you know everything that's going to get changed. So it's going to be creating a whole bunch of things for this one instance. And so now that we've run the Terraform plan, we can now run the Terraform apply to actually run our code. So we'll do Terraform apply. And you'll see that Terraform apply will do something similar to Terraform plan, where it'll actually take a look at your code and then figure out the changes that'll take place. And so this is just another security check, so you can just verify that you're not going to break anything. And it's going to ask you, do you want to make these changes? So to approve them, hit yes. And it's going to run our code now. And hopefully, we don't break anything and everything passes. But you can see here, it's creating our first server right now as we speak. So we'll let that run. It's going to take some time. Usually creating instances can take a little while. Sometimes up to like 5-10 minutes, depending on what kind of instance you're deploying. Especially if you're on something like Azure. I think Azure takes a little while for some reason. Well, actually, that was pretty quick. But you can see that it completed, and it'll give you kind of like a quick overview of the total number of changes that were made. So we can see 1 resource was added, 0 were changed, and 0 were destroyed. And, as usual, just because Terraform says it finished and completed, we want to double check within AWS to see if that instance actually got created. So you can see that this was the state before we ran Terraform. So we've got 2 in a terminated state and 1 in a running state. So if I hit this little refresh button, it's going to just refresh it. And you can see now we have 2 in a running state. And this instance right here is the one that got deployed by Terraform, because you can still see that it's in an initializing state. But if we click on this and just kind of take a look at the details, you can see that it's a T2 micro instance like we specified. And you can see the AMI. So this is the AMI, which is using Ubuntu 18.04. And so there you have it, guys. You've successfully deployed your first EC2 instance using Terraform. And hopefully you can really start to see the power of Terraform just from this simple example. Because, what if we wanted to deploy 50 different instances, right? Would you want to manually have to click through these windows 50 different times? Or would you want to just copy and paste a couple of instances right here, and then you're good to go? Okay, so we've successfully deployed our first EC2 instance using Terraform. And what I want to do now is I want you guys to try and guess what will happen if we do another Terraform apply. Don't actually run this, just try to figure out what would happen. And I can pretty much guarantee you that your guess is going to be incorrect. I'm assuming most of you guys that are watching are probably going to assume that, well, Terraform is going to run this code again, and it's going to create another EC2 instance. So we would end up with 2 EC2 instances. And I'm going to tell you that that is incorrect. In fact, and the reason for that is that Terraform is written in a declarative manner. And what that means is that we're not actually giving Terraform a bunch of steps to carry out like a normal program would. Right, so it's not going to go through this code and just run through each one step by step, right? So if we pasted this one, it's not going to go and say, okay, we want to deploy one resource and then we want to deploy another resource. Instead, what's actually happening is that we're telling Terraform what we want our infrastructure to look like in the end. So we're giving it the exact blueprint of what our infrastructure should look like. And so if we look at our Terraform file here, it says that we should have just one AWS instance in our infrastructure, and that is it. So no matter how many times we apply Terraform or run Terraform apply, we should always just have one AWS instance, and that's this specific instance, right? So that's why in Terraform, we're not giving it a set of instructions to carry out. We're trying to define what our entire infrastructure should look like. And then Terraform will go in and then figure out exactly what needs to get deployed, what needs to remain the same, what needs to get deleted, and so that our actual state in AWS matches what's being defined in our Terraform code. So if we do Terraform, well, before we do apply, I always recommend you do a Terraform plan. So if we do a Terraform plan again, it's going to tell us what the changes that will take place. And you'll see that it's actually refreshing the state. So if we look here, it's refreshing the state of our AWS instance that we actually deployed just to make sure it's still there and there aren't any issues with it and that it matches what's here. And then you can see here, it's telling us that, oh, look, no changes were made or no changes need to be made. Infrastructure is already up to date and matches what's defined in our Terraform file. So if I do a Terraform apply, hit enter, it's going to once again refresh the state of our AWS instance. So it's just basically talking to the AWS server, just making sure that instance is still alive and working. And then once again, when we run the Terraform apply, it figured out that, look, nothing needed to get added, changed, or destroyed. Okay. And this is an important concept. I think it's a little bit challenging at first, but just know that once again, everything's being defined in a declarative manner, which is a little different than a lot of other automation tools. But keeping that in mind, I want to make a few changes just to show you guys, what Terraform will do when we start adding, extra properties to this EC2 instance. So the simplest change we can make is adding a tag. So if you aren't familiar with tags, right, you can give any AWS instance a specific set of tags to kind of identify them, and so that you can actually search for them and filter by those tags. So we'll go back to our code, and actually, let's go back to the documentation to see how we apply a tag. So this is all you have to do. You just do tags, and then you just provide in all the tags that you want to give it. So we'll copy this, and I'm going to paste it in there. Oops. And I'm just going to change this tag. I'm just going to call this, we'll call this Ubuntu server. We'll just call it Ubuntu. So we're going to give it a tag of Ubuntu. Make sure you save the code. And we're going to do a Terraform plan now, just to see what changes are going to take place. So it's going to refresh the state. And now it printed out some changes that are going to take place. And so, you'll see that anytime we're going to change an existing resource, you'll see this yellowish, orangish color with that little tilde. And so it's saying that we're going to change something regarding this resource right here that we already deployed. That's the My First Server resource. And if we scroll down a bit, you'll see that this is the change that's going to be made. So it's going to add in a new tag. Okay. So Terraform was smart enough to know that, look, we know what the current state is of our resource that's deployed on Amazon. Right now, it has no tags, but in our code, we're telling it to have a tag. So then Terraform goes in and figures out, oh, okay, I need to add a specific tag to this resource. So we'll do a Terraform apply now. It's going to run that same check we just did. And once it's done doing that, you can see that it's going to make one change. And we're going to say yes, just so we can complete those changes. Okay, and it successfully completed that. It's changed one resource. We'll go back to the console. We always want to make sure that the changes actually took place. Don't just take Terraform's word for it. Okay, and so you can see right here already the name got populated. So that's the special tag for naming a resource. But if you click on the resource and just scroll down to tags someplace, I forget where it is. Should be, where is it? Oh, here we go. Yeah, I forgot on AWS, you actually have to select this tag. And so you can see here, we've got our tag, which has a key of name and a value of Ubuntu. And if we remove that, or comment it out and then hit save, we can do a Terraform apply again. And Terraform is going to talk with the AWS API just to get all the information about our server again. And it's going to see that it has a tag, but we're telling it to not have any tags. So then it's going to make the necessary changes. And so all we can see here is that, look, we're going to go from a name of Ubuntu to null, which means we're going to remove that tag. So we'll run that and it should remove that tag. Okay, and if we hit refresh, you can see that now there are no longer any tags. Up to this point, I showed you guys how to create instances as well as modify instances. I think the next logical step is to show you guys how to destroy instances. And so if we want to destroy the instance that we created, we can do a Terraform destroy. And once again, when we run a Terraform destroy, it's going to do a refresh of our state, and it's going to show us what are the changes that are going to be made. So you can see here, anything with that dark red dash means we're going to delete it. So we're going to delete that one EC2 instance that we've deployed, and we're going to delete everything kind of associated with that. And so when we hit yes, it should run that and it should remove it from AWS. All right, so it successfully destroyed our resource. We go back to the AWS console. You can see if we hit a refresh, this guy should get removed. And so you can see it's now in a terminated state. And then I forget how long it normally takes, maybe like 2 more hours, and then it'll get completely removed from the AWS console. But that's how you destroy your all the instances that were deployed using Terraform. Keep in mind though, if we had like, I don't know, 10 of these resources, what's going to happen is when you do a Terraform destroy, it's going to destroy every single resource that was created by Terraform. So keep in mind, if you want to destroy a single resource, there are some parameters that you have to pass in to actually make that work. By default, the Terraform destroy will destroy your entire infrastructure. So you probably won't be actually running that very often within a production environment. Usually you're just doing Terraform applies and then making changes and then applying those changes. However, I do want to show you another thing that we can easily do. So first of all, let's actually deploy this once again. So I'm just going to do a Terraform apply. We're going to have to wait for this to get deployed again. Okay, and once it's deployed, let's just quickly double check that it's been created. So this is the new instance that's been created. And what I want to show you is really the power of that declarative style of writing code that I mentioned earlier. So instead of doing a Terraform destroy to destroy a specific instance, what we can do is we can just delete this code right here, right? And so instead of deleting it, I'm just going to comment it out for now, which is doing the same thing as essentially removing that code altogether. So if we hit save, Terraform will see that, look at this, and within our code, there's no resources being defined. And so Terraform will see that, it'll check the state, and it'll see that there's actually an EC2 instance deployed by Terraform, and it'll say, hey, wait a minute, that doesn't match. We should not have any resources deployed based off of this Terraform file, so let me go ahead and delete that one resource that we've deployed. So if I do a Terraform apply, it's going to refresh the state like it did before. So it's refreshing that instance that we created, and it's saying, whoa, wait a minute, right? Based off our code, there should not be an AWS instance deployed at all. So let me go ahead and destroy this sucker. So if we hit yes, he's going to end up destroying it. And so that's just another example of that declarative nature of Terraform. And so you can use that as a tool to, delete instances or delete any resource within AWS. As long as you just delete it from your Terraform file and then run apply, Terraform's going to figure out what you want and what you don't want. So you don't actually have to delete it from AWS or do a Terraform destroy. Okay, so it looks like it's destroyed it. Let's just go back to the console, double check. And so it looks like it's already terminated it. So it refreshed it for us. And so there you have it, guys. So that's how you delete resources within Terraform. You can do it through the Terraform destroy, or you can just remove it from your code and do a Terraform apply, and Terraform will figure out what it needs to delete. Till now, all we've done was deploy an AWS instance, but obviously, anything you can do with the AWS console, we can do it in Terraform. So I want to start taking advantage of some of the other things that Terraform can do, and I want to start playing around with other resources within AWS. So if you haven't already done so, go ahead and destroy the AWS instance that you created. You want to do it through Terraform, of course. Don't do it through the console. So either do a Terraform destroy or just delete this resource, and then run a Terraform apply to get that resource removed. And once you have it removed, what I want to do now is I want to explore how to create a VPC, and I want to explore how to create a subnet within that new VPC. Okay. And so if you don't know what a VPC is, it just stands for Virtual Private Cloud. So it's just a private isolated network within your AWS environment. So you can create as many VPCs as you want, or there may be a limit, but you can have a lot of VPCs, and then each one of these VPCs by default is going to be isolated from one another. And so to create a VPC, the first thing that we want to do is always just navigate towards the documentation. So if you just search for a resource AWS_VPC, that's going to show you how to create a VPC. And you'll see that the configuration is dead simple, right? All you have to do is just provide a CIDR block. And so this just means that for our VPC, the 10.0/16 is going to be the network that's going to be used for that VPC. So let's just copy this and we'll paste it in here to create a VPC. And I'm going to change this name, so we can give this any name that we want. So I'll just call this my first VPC. And keep in mind that this is just the name that's going to be used within our Terraform. So anytime we want to reference this resource, we can just reference first-VPC. And if we want to give the name within AWS, we can provide it a tag. And so you can take a look at the configs here, and then this is how you do it. So there's a specific tag for naming things, and that's called name with the capital N. And we'll call this our production VPC. Okay. And so this, once we run this, we'll create a VPC. However, what I want to do now is I want to create a subnet within that VPC. And this is going to be a little bit more challenging, and I'm going to show you why in a second. But if we navigate to the AWS subnet resource, and if you don't know how to find it, the first thing I always do is just do Terraform and then, AWS and then whatever resource you're trying to configure. So if you want to see a subnet, just search for subnet. And it's usually going to be either the first or the second one. So we want AWS_subnet. So it's going to be the second link in this case. And you can see how to configure it. It's pretty easy. All right. So we just specify resource, AWS subnet, then a name. And then we have to specify a VPC ID. We also have to specify a CIDR block. So what subnet do we want to use for that subnet? That makes sense. And then any necessary tags. So let's copy this and let's paste it down here. And so we're going to change up a few things. I'm going to change this I'm going to call this subnet 1. And the CIDR block 10.0.1.0/24, that's fine. Just make sure it falls within this range. And then for tags, I'm going to call this prod subnet. Okay, and here we have to specify the VPC ID. And you're probably thinking, well, we haven't deployed this VPC. How do we get the VPC ID, right? I can't go into the console and get it because we haven't actually created that VPC. This is where the power of Terraform comes in, right? We can reference other resources that are being defined within our code. So we want to reference this VPC that we're creating and pass in the ID down to this field. And the way to do that is pretty simple. Right, all we have to do is we have to specify the resource name. So we'll do AWS_VPC just like it is up here. Then we do a dot. Then we have to take the name of it. So we'll take this name. And so that's why the naming is important. Paste it here. And then we have to get a specific property off that resource. And so every property has an ID. Every resource has an ID property that we can access. So this value right here is going to get the ID of this VPC that gets created from the line above, okay? And so that's how we can reference other resources that are being defined in our code, right? So you just, what I do is, for simplicity's sake, I usually just copy this, whatever's between the quotations, and I just remove these two quotes, put in a dot, and then put in a .id. That's my little shortcut. Okay, so I think we're good to go. Let's try to run this and deploy it. So we'll do a Terraform apply. Actually, let's do a Terraform. Yeah, let's do a Terraform apply. And so we'll see all the changes that are being made. And let's scroll up a bit. And so you'll see that we're creating a subnet. And we're also going to be creating our VPC. And you'll see all the details that are being passed into it. So we can hit yes at this point, and it's going to deploy that VPC as well as that subnet. Okay, it looks like it's already done. That was super quick. I guess it's really just EC2 instances that take a long time. But if we go back to our dashboard, what is this banner? Who cares? Anyways, let's go to services, search for VPC. And let's take a look. And so you can see by default, there's a default VPC for every user. So this is the default VPC that gets created. So we can ignore that. I just wanted to make sure you guys understood that if you were confused as to why there's two VPCs. But this is the VPC that we created from Terraform. And if we take a look at the details, we've got the CIDR block that we assigned to it. And then the tags, obviously the name being production. And if we go to our subnets, so there's going to be a whole bunch of subnets here. But once again, these are all part of the default VPC that gets created. And we want to just take a look at the one we created, which is prod-subnet. And so if we go here, we'll see that the VPC that this subnet resides in is this VPC, which is prod, which is going to be the VPC that we created within Terraform. And then we also have the CIDR block, which is the 10.0.1.0/24. And so that's pretty much it. Obviously, there's a tag, which is the name, which we can see right up there. Now, there's one thing I want to point out. You're probably thinking, well, since when we create the subnet and we're referencing the VPC resource has to get declared first. And what may be shocking is it actually does not need to be defined first. And I'm gonna prove that to you. We're gonna do a Terraform destroy. We're gonna let that get destroyed real quick. Okay, so it's been destroyed. Let's just double check and make sure. Okay, and so that's gone. And what I'm going to do is just to prove my point, I'm going to copy this or cut it, and I'm going to paste it right above the VPC. So now within our code, we're defining the subnet, and we're referencing the VPC, even though the VPC is defined beneath it. And once again, guys, this is just to show you guys that the order in which you place your code does not matter within Terraform, which is a little confusing, right? If you're familiar with programming, right, it always follows a sequential order, starting from the top and working to the bottom. So let's make sure we save everything, and then let's do a Terraform apply. And guys, if you get tired of having to hit yes whenever you want to destroy or create something, you can always do the -- auto approve, and that's going to skip that step. So that way you can just run it, step away from your seat, go grab something to eat, and then just come back when it's done. And so you can see here, even though the subnet was declared first, you can see that Terraform, actually, I realized that this window is probably not that big for you guys. And so I'm going to make this a little bigger for you guys. Let's see. Is there a way to do that? Maybe if I just do a Control+. There we go. But if you take a look at the order in which things are created, you'll see that we create the VPC first. And it took 3 seconds to complete, and then we created the subnet. So Terraform does not care which order, the order in which you define things, because Terraform's intelligent enough to figure out what needs to get created first. So Terraform knows that a subnet belongs in a VPC, and since this subnet is referencing the VPC that we're creating, it knows to create the VPC first and then create the subnet. Okay, so Terraform is very intelligent. It can figure out what needs to get created, so you don't have to worry about any of that nonsense. It'll figure out what needs to be done. However, I will say this, there are certain instances where it can't. However, if you look at the documentation, it'll always tell you whenever Terraform can't figure out what order to create things, and it'll give you a workaround. So like usually you'll have to pass in an extra flag that says one resource depends on another, but for the most part, Terraform will figure out everything for you. Now, if you guys have been following along, you may have noticed that there's a couple of extra files that gets created on the left side. And so you may be wondering what those mean. And, that's what I want to cover in this section. So we'll start off with this .terraform folder. So this folder gets created whenever we initialize any plugins. So when we did a Terraform init, right? The Terraform init, it's going to create that directory and then it's going to install all of the necessary plugins for our code to run in this folder. So since we have just one provider, all of the code for the AWS provider is going to get installed into there. And just to prove that to you guys, I'm going to delete this real quick. And it's okay, it's not going to break our code. It looks like it just deleted one of those folders. I want to delete all of them. All right. Okay, so they're all deleted. And if I try to do a Terraform apply, it's going to throw an error saying, look at this, we don't have a AWS provider. And so what we have to do is we have to initialize it again. So if I do a Terraform init, it's going to do that initialization process. And when it does that, it's going to create that folder that we just deleted. And there you go. So we see the .terraform folder and it's got the configs for AWS right here. Now moving on to the second folder, or sorry, the second file that you may be wondering about, that's going to be the terraform.tf_state. So what this file is that it represents all of the state for Terraform. And basically anytime we create a resource within AWS or any cloud provider, we need a way for Terraform to keep track of everything it's created, right? Because that way, if we go to modify a parameter like add an extra tag or maybe change the instance type from like a T2 micro to another size, right? It needs to be able to check, what is the current status of that resource? What are its configurations and compare to what's in the code. And the way it does that is it just creates a simple text file. And so we've got this terraform.tf_state, and it looks like it's in a JSON format. I can't remember if it is fully JSON. It may not be. Don't quote me on that. But we can basically store all of the resources that we create in this state file. So you can see we've got the AWS provider. And if we just kind of look through it real quick, we can see all the resources it's created. So we've got the first VPC that we created. And so you can see all the details about that VPC. And then I think someplace there's going to be a subnet. So this is the one that covers the subnet. And this is going to have all of the information regarding the subnet. So this file is very important. So if for some reason you ever go into this and start deleting things, you will break Terraform. And so Terraform will have a mismatched state from what's actually being deployed into AWS. So never mess around with the TF_state file. It's a very important file, and it's absolutely crucial to the overall functionality of Terraform. And just to kind of show you how this state file gets updated, I'm just going to create another VPC. And so I'm just going to take this, copy this, and we'll just paste it down here. And I'm going to call this, we'll call this second VPC. And I'm just going to change the CIDR block, and we'll change this name to, let's say, dev. And might as well just create a new subnet for that guy as well. I'll call this subnet 2. And for the VPC ID, I'm going to reference this VPC. So, whoops, that's a typo. And we're going to just change this to second-VPC. And I'm going to change the subnet to make sure that this subnet resides within this CIDR block. And we'll call this dev subnet. Now, if I do a Terraform apply, and then do a -- auto approve. And once again, typos all over the place. Now, if we go back to our TF_state file, we can take a look at it. We'll see that there we had subnet 1 already. That was already in there. And then we've got, now we have subnet 2, right? So you can see that anytime we create an instance or modify an instance within AWS, we're going to update our state file so that we can keep track of all of that information. All right, guys, so that's all I wanted to cover in this video. till now, we've only been doing very simple tasks like creating an EC2 instance or creating a VPC or a subnet, and we haven't even been able to log into that EC2 instance. And so, what I wanted to do was, with everything that we've learned so far in Terraform, I want to walk you through how to create an EC2 instance, deploy it on a custom VPC, on a custom subnet, and assign it a public IP address so that not only can we SSH to it and connect to it and make changes on it, we can also automatically set up a web server to run on it so that we can handle web traffic. And this task, it seems like a very simple task with a couple of steps, but it's actually a little more complicated than you think. But luckily, we don't actually have to do anything from a Terraform perspective that we don't already know how to do. And so I'm going to walk you through that. And I've actually outlined all of the steps that are necessary to do this. So there's 9 total steps. Technically 10. We're going to have to do one step outside of Terraform just to keep things a little simple. We could do it through Terraform, but that would get a little more complicated. But just to walk you through the steps, we're going to create a custom VPC. And then within that VPC, we're going to designate a internet gateway. And the reason we need to have an internet gateway is so that we can actually send traffic out to the internet, because we do want to be able to assign a public IP address to this server so that anybody in the world can reach it. Then the next thing that we need to do is we want to create a custom route table. Technically, this would have been optional, but I thought it would be cool to show you guys because these are all things that you need to be able to do. So I wanted to make sure I walk you through that. We're going to then create a subnet in step 4. And then anytime you create a subnet, we have to assign it to a route table, or then it'll get assigned to the default route table for your VPC. And so this will just associate the two together. Then we're going to create a security group. And the security group is just responsible for determining what kind of traffic is allowed to get to any one of your EC2 instances. So since this is a web server, we're going to allow port 80 and port 443 for HTTP and HTTPS traffic. And we're also going to allow port 22 so that we can SSH to it and, obviously connect to it and make changes to it. We're going to create a custom interface, and that's going to be assigned to the subnet that was created in step 4. And we'll assign an elastic IP. So an elastic IP in Amazon world is just a public IP address that's routable on the internet. And then we're going to assign that to the network interface we created in step 7. And then finally, we're going to create an Ubuntu server. We're going to automatically, through Terraform, install and enable Apache. And then we're going to assign that IP address or that network interface that we created in step 7 to that Ubuntu server. And at that point, we should have a live running web server, and we should be able to connect to it and, do whatever we want with it. All right, guys. So, before we get started, the first thing that we need to do actually is create a key pair within AWS. And the key pair is just going to allow us to connect to these devices. So AWS requires us to set up access keys so that we can connect to these devices. So to set up the keys, we need to go to the EC2 section. And then there's a section within here called key pairs. Here we go. And so you can see I have one key pair here already, but I'll walk you through how to create a new one. So we'll just do create new key pair. And here we'll just give it a name. Okay. So we'll call this, whoops. We'll just call this access key. You want to give it a better name than this. I just couldn't think of one. Okay, how about this? We'll call this main key, main-key. So there's 2 different file formats that you can use. Go ahead and download the PEM format for now. I'll show you how to actually convert this to a PPK if you want to use PuTTY. Moving forward though, if you're mainly a Windows user, download the PPK so that you can use it with PuTTY. If you're using Mac or Linux, you're going to want the PEM file. So, download that. But for now, even if you are using a Windows machine, download the PEM and I'll show you how to convert it to a PPK. So we'll create this key pair and it's going to automatically download this for you. So just remember where it's getting saved to. So it's probably going to get saved in your downloads folder and just keep that in mind. Okay, so now that we have our key pair set, this key is going to allow us to actually connect to our server once we deploy it. But, let's go through this step by step and tackle each step. And you'll see that just how easy it is to create all these resources. And I'll obviously point you to all the necessary documentation so that if you guys want to read up further on it, you can. And so the first step, create a VPC. You guys have already done this, but I'll walk you through that. So obviously, I already forgot how to actually configure one. So just search for Terraform AWS VPC. This is all I do, guys. Just Google it, and Google will tell you what to do. And so here we're going to define a resource, a VPC resource. So I'm just going to copy and paste that. I'm going to keep this as the same sided block. It doesn't really matter for the purpose of this project. Now we need to create an internet gateway. So this is something new, but once again, the power of Google. We'll do Terraform, AWS, and then what was it called? Internet gateway. Okay, so there's a couple of things. Really, the only thing you have to pass in is the VPC ID. So we'll just copy this, and I'm going to just go in here, paste that in there. Don't really care about tags for now. And we need to pass it the VPC ID. So remember, we can reference another resource within our Terraform code. And so we'll just reference this VPC. So we do AWS underscore VPC, then well, let me give this a more descriptive name. I don't like main. We'll call this prod VPC. Actually, let's give this a tag as well. Why not? And we'll just call this production. And so to reference this, we'll do AWS underscore VPC, then dot, then the name. So prod dash VPC. And then we have to do a dot and then ID because we always want the ID property of this resource. We don't want the resource itself. And don't worry about giving us a tag. So that's all we need to do. Now we have to create a custom route table. So this is something that's new again. So we'll just search for that Terraform AWS route table. And, obviously we already have this open, so we could just kind of navigate to wherever it is, but there's just so many resources. It just takes forever to find what you're looking for. So I always just Google it. And so here we want the AWS route table, and it's going to give us an example. So just copy this, and I'll take you, I'll explain step by step what each line is doing. And I'm going to give this a name. We'll call this prod route table. And we have to reference the VPC ID, so we can just copy what we did with the internet gateway. And we don't really need a tag for this route. Let's give it a name. I think we'll just call this prod as well. Okay, and then now here, this is where we define the routes for this route table. So if you look at this, what this is saying is that for the subnet, the 10.0.1.0/24, we're going to send it to the internet gateway. However, what I want to do is I just want to set up a default route, which means all traffic is going to get sent to the internet gateway. So to do a default route, if you guys aren't familiar with networking, you just do the 0.0.0/0, and this is going to send all traffic, all IPv4 traffic, wherever this route points. And this is the old syntax of referencing other resources. But remember, we're just going to do it the same way we did for the VPC. So let's find the internet, the AWS Internet Gateway. And so we just do AWS underscore internet underscore gateway. Then you do dot, and then we just reference the name. So we just give the name of GW, and then we want the ID property. Okay, and so that's all we have to do to create a default route. And we can also create an IPv6 default route. I'm not using IPv6, but we might as well go put it in. And so for an IPv6 default route, it's already been provided. So you just do ::/0. It's the equivalent of this, but for IPv6. And we can delete this and just point it to the same internet gateway. And once again, this is just going to make it so that our traffic from the subnet that we're going to create can get out to the internet. All right, now we have to create a subnet where our web server is going to reside on. And this we don't need to kind of search how to do because we've already done this before. So resource, AWS underscore subnet. And then let's give it a name. I'm just going to call it subnet-1. And then we have to give it a VPC ID. So let's just grab what we did here for the internet gateway and just copy that. A lot of copying and pasting here, guys. And then we have to give it the actual subnet that we're going to use. So the setter block. And so I'm going to use the 10.0.1.0/24 subnet. And there's also another optional property. So we can actually specify what availability zone we want to use. And if you don't know what an availability zone is, within a region, it's not that AWS just has one data center. Within each region, they actually have a couple of data centers. I'm not really sure how many. Maybe it's like 3 to 5. And so that way, if one of their data centers goes down in a region, the whole region doesn't go down. So they have redundancy, and so you can actually deploy resources to a specific availability zone, and we can pass that in by passing in the availability zone property, and then just specifying the name. So we'll just do US-East-1A. And so there's going to be US East-1A, 1B, 1C, and so on, but we're just going to send it to 1A. And then we can give this a tag as well. So we'll set the name to prod underscore or dash subnet. And so now we've created a subnet, we've created a route table, but we actually have to assign this subnet to this route table. And so there's another resource type within Terraform that's called route table association. And we'll just, let me pull up the documentation so you guys don't get confused. So we'll do Terraform AWS route table association. And all this does is it just associates a subnet with a route table. And so you can see here we have to pass in the subnet ID as well as the route table ID. So we'll copy this. And then we just need to update the subnet and the route table. So we can remove that and pass in our subnet. So AWS underscore subnet dot subnet dash one dot ID. And then let's grab the route table. So I'll just copy this. Paste that in there, remove the quotations. Whoops. And then just join them together with a dot. And then we want to grab the ID. And that's all we have to do for the route table association. We could just leave it as the name of A because we're not going to reference that anyways. So the next thing we need to do is create a security group. This is something new again. And so it's always good to make sure that you have a security policy that's really clamped down on only the protocols that you need. And so we'll just search for that. And I'm just going to copy this example and walk you through what's happening. So let's give this a name. We're going to call this allow web traffic. And we're going to change this to allow underscore web. So this security group is really just going to be there to allow just web traffic. So we just want port 22, port 80, and port 443. And description, we can just change this to allow web traffic. And we have to point to our VPC. So we already know how to do that. We can just copy the one from the subnet. Now, this is where we actually apply the different rules. So we have ingress policy as well as egress policy. So in this example, what this is saying is that we are going to allow TCP traffic on port 443, right? So the from port and the to port just means it allows us to specify a range of ports. So if I did 443 to 447, that means we would allow ports 443 through 447. So when you just do the same number, it means we're allowing just that port. And then this is the protocol. So you have TCP, you have UDP, and so on. And then you have, we can actually clamp down on what subnets can actually reach this box. So we can actually put in like our own IP address of our work computer or something so that only certain devices can actually reach this. And so sometimes it's best not to open it up to the internet, but since we're creating a web server that's meant to be used by anyone, we want to allow it so that anyone can use it. So we'll change this to 000. That default, that means any IP address can access it. But if you just wanted like a one specific IP, you could just do like a 1.1.1, /32, and then this would mean that just that IP address can access it. But we want everyone to be able to access it, so we'll do that. And we can have as many ingress and egress policies as we want. And so this is actually technically for HTTPS traffic. So HTTPS traffic. I'm just going to call it that. And what we want is not just HTTPS, but we want port 80 and port 22. So we can just copy this ingress rule and paste it a couple of times. I'm going to hit save just so it formats it. And this is going to be HTTP. And HTTP resides on port 80. TCP, once again, so all web traffic's TCP. And then we want it from any IP address. And then finally, we want one for SSH. So this is going to be port 22, TCP, and then, yes, any IP address. And if you look at the example for the egress, this is just saying that, we're allowing all ports in the egress direction. And when you put it in -1 for the protocol, it means any protocol. And for the CIDR block, it means any IP address. So this is exactly what we want for the egress policy. What's more concerning is always setting up the ingress policy. And we can change the tag to allow, call it allow web. All right. Now we want to create a network interface. So let's go to documentation for that. So Terraform AWS network interface. And so I'm going to copy this. We're going to change the name. I'm going to call this web server Nick. And so we need to assign this Nick to the subnet that we created. So let's find our subnet. Where'd it go? Here we go. And don't forget to grab just the ID. And here we need to specify an IP. So what IP do we want to give the server? We can pick any IP address within the subnet. Well, not technically any IP address. AWS is going to reserve a couple of addresses like the .1 and a couple of other ones. So I'm just going to do 10.0.1.50. So 10.0.1.50. And then finally, we have to pass in a list of security groups. And so let's pass in the security group that we just created in the step above. And we can actually attach it to a device now, but we're going to skip that, and we can actually specify what NIC we want to use when we actually go to the provisioning section for an EC2 instance. So we're going to delete that part, and we don't need that for now. And then now, so this created the private IP address for the host, but we also want to assign it a public IP address so that anybody on the internet can access it. And to do that, we need to create an AWS Elastic IP. So if we search for Terraform AWS EIP, all we have to do is just, we can just grab this as an example. So VPC equals true. I forgot what that actually does. We can take a look at the documentation. So this just means Boolean if the EIP is in a VPC or not. So it is in a VPC, so we have to set it to true. And then network interface. So we can specify what network interface we want to assign it to, which is the one we created in step 7. So we can copy this. And then when it says associate with private IP, it's going to be the private IP that we gave right here. And also, I guess I forgot to point out that, here we're passing in a list of IP. So technically we could have given more than one, But we're just going to assign one here, and then we can just reference that here. We'll do 10.0.1.50. And now, I told you guys that Terraform, does not care about the order, and it will figure out the order at which things need to be deployed so that everything works. However, there are certain gotchas, and this is one of the gotchas right here, is that the AWS EIP relies on the deployment of the Internet Gateway, which is created up here. And so if you try to do this through the console and you try to create an Elastic IP and assign it to a device that's on a subnet that or in a VPC that doesn't have an internet gateway, it'll throw an error because for you to have a public IP address, you need to have an internet gateway. So deploying an Elastic IP requires the internet gateway to be deployed first before the actual Elastic IP gets deployed. And I guess Terraform by default can't figure that on its own. And if you actually take a look at the documentation, it even lets you know that. So it says Elastic IPs may require internet gateway to exist prior to association. So you can use the depends on to set an explicit dependency on the internet gateway. So what we can do is exactly what it told us to do. We can set a depends on flag and set that equal to the internet gateway that we created. And here we actually don't need to specify the .id. We want to actually reference the whole object and not just the ID. All right, guys, we're almost done. We just got one last step, and that's to create our Ubuntu server. And here we're going to do resource AWS underscore instance. And then we'll call this a web-server-instance. The AMI, so let's grab the AMI from our console again. So if we do launch instance, and then we'll just search for Ubuntu, and we'll grab the first AMI right here. The instance type, we're going to do the T2 micro again because it's free. And here we can also set an availability zone. And I'm going to make sure, this is very important, to actually set this to the same one that we used for our subnet. And so if you remember, we go all the way back to the top. Let's see, where is it? Where's our subnet? Here we go. Our subnet, we passed in this availability zone, the -1A. And there's a reason why I hard coded the availability zone, because if you don't hard code it, Amazon will pick a random availability zone to deploy that. And I've had a couple of times where the subnet would get deployed in one availability zone, and then my interface would get deployed in another availability zone, and then I couldn't combine the two because they're essentially in two different data centers. So whenever you get an option, make sure you to hard code the availability zone, or then you could lead to issues where it says oh, you can't have your server in one availability zone and then your subnet in another one. It just creates all sorts of issues. So anytime in the documentation it gives you an option to pass it in, go ahead and pass it in. Now, if you remember the key pair that we created, we need to reference that so that we can actually access our device. And so let me go back to the key pair. What did I call it? Main-key. Main-key. And now we can specify the network interface. We do network underscore interface. And if you're wondering where I'm getting all of this, it's all in the documentation. So if I pull up AWS Terraform instance, it's going to walk us through how to do all of this. But what we want to do is we want to scroll down, look for network interface. So there's a network interface section within, it didn't take me to the right section. Here we go. There's a network interface section. So we have to define a network interface block. And this is what a block looks like. So you can actually create another block within our resource to define a few extra parameters. And so the first thing that we have to do is provide a device index. And all this is doing is that, for any EC2 instance that we deploy, we can give it a ton of different interfaces, right? We don't have to just give it one. So we have to tell it which interface you want it to be, right? Because it's going to get labeled like Ethernet 1, Ethernet 2, Ethernet 3, and so on. So we're going to make sure that this is his first interface. And you can do that by specifying the device index and setting it to 0. And we want to set that to 0 because, it's kind of like uh, like in any programming language, the first number you start with is 0 instead of 1. So this is going to mean that this is the first network interface associated with this device. And then we have to specify the network interface ID. So we just have to reference this network interface. So we'll copy that. And now, guys, this is where the actual magic happens here. So what we're going to do is we're going to tell Terraform to, on deployment of this server, to actually run a few commands on the server so that we can automatically install Apache. And the way to do that is to use the user underscore data block. And what we have to do is we have to pass in, and this is going to look a little goofy, but we just say EOF. And I forget what this stands for, but you just put that in there. And then now we just type in all of the commands we want to run. So just like with any bash script, we want to start off with with this goofy header that you always need. And then now we just specify all of the commands that we want to run. So we'll do a sudo apt update -y. We'll do a sudo apt install apache 2-y. And then we'll do a sudo systemctl start apache 2. And then finally, this last one's kind of optional, but what I'm going to do is I'm going to copy some text to the index.html file that gets served by the web server so that we can confirm that, all of these commands actually worked. And I'm just going to say, we'll say echo, and then we want to send a string of text. We'll just say your very first web server. And we want to redirect that to /var/www/html/index.html. And hopefully I wrote all of that without a typo. And then, obviously you guys can run any command that you want. So you can put in whatever command. So you can install any package. You can modify and configure files all from here. But once you're done entering in all your commands, you just do EOF. So EOF at the top starts all of the configs, and then the EOF at the bottom basically tells Terraform that we're done. And then lastly, let's give it some tags. So we'll say name equals, and we'll just call this web server. Let's hit save. And now we're going to do a Terraform apply. And it looks like I messed something up. So let's see. Depends on what happened here. A static list expression is required. Okay. I already know my mistake. So when you use the depends on parameter, you actually have to pass it in as a list. And so the reason we pass it in as a list is because we can actually specify multiple things that we need to wait on before we actually run the Elastic IP. So if we wanted to make sure that the VPC got created, we can specify that, as well as the subnet and so on. So you can put in as many criteria as you want. So that's why we have to pass it in as a list. And let's do Terraform apply again. Hopefully it goes through this time. Looks like it's good so far. We'll do yes, and let's just now it's time to start praying. And it looks like we got another error on line 25. Let's see what happened here. Yep, and I already figured out the mistake. This should be under the AWS route table. This should not be egress only gateway ID. This should just be gateway ID like it is up here. That was just because I copied and pasted and I forgot to change it. But just to make sure you guys understand what's happening here, all we're really doing is we're just saying that our default route for IPv4 and IPv6 is going to go towards the internet gateway so that we can get out to the internet. All right, it looks like it's done, guys. So let's just take a look. Let's just verify in the console that everything is okay. And so let's go to our EC2 instance. Let's see if it got created. And so we've got one that's initializing right now, and that's our web server. You got the previous one. Obviously, I did a dry run before this video, although I still messed up a whole bunch of things. But this is our EC2 instance. I think things look good. Obviously, we can go through each and everything, make sure our VPC is good, make sure our subnet's good, make sure our route table's good. But that's just a waste of time because I already know they're okay. Instead, what I want to do is I want to actually show you how we can connect to this device. Or actually, let's wait till this is finished initializing. And once it's initialized, let's just navigate to this IP address and see what happens. So I think it's probably at this point already running. So let's just go to that, and then we'll just go to the IP address. So copy the IP address in your web browser, go to that, and you can see your very first web browser. So this just confirms that we installed Apache on our server, and we copied that text to the index.html file to get served to all the users. And so that just confirms that everything is working okay. However, now what I want to do is I want to show you guys how to actually connect to that device. Since it has a public IP, we can actually SSH to it. And the way to do that, it's going to vary depending on what operating system you're on. So if you're on Windows, I'm going to walk you through that now. And then in a second, I'll show you guys how to do that in on a Linux or a Mac machine. So if you're on Windows, the first thing that you need to do is download a software called Putty. It's a little annoying that we need to use Putty, but just search for Putty, and then let's see if I can. So just download it here. Select this button, and then you can just download the installer. So get the 64-bit if you're using 64-bit, or get the 32-bit if you're using the 32-bit. So after you install it, just go to your search bar and just search for Putty, and you'll see that there's two applications that actually got installed. There's Putty and PuttyGen. And the first thing that we need to do is we actually need to open up PuttyGen. And the reason we need to do this is because this is a PEM file. And I told you guys that there's the PPK file or PKK. I forget which one it is. I think it's PPK. And then there's the PEM file. So Linux machines like to use the PEM file. However, Putty likes to use the PKK file or the PPK file, whatever it is. I can't remember. And so we have to convert this PEM file to the right format to be able to use it on a Windows machine. So the way to do that is open up the PuttyGen application, like I just showed you, and hit this load button. And here, select all files. And we've got this main-key.pem. So hit open, and it's import this. And then all we need to do is select save private key. And then it's going to give you this warning. Go ahead and ignore it and just hit yes. And then give it a name. So I'm just going to call this main-key again. And it's going to save it as a PPK file. So I'll have a PEM version as well as a PPK version. So I can use it on either machine. We'll hit save, and I think it should have created it. So we can just double check. And let me go to my downloads folder real quick. And if I move that over here, yeah, you can see that now we have the main-key PPK file as well as the PEM file. So now what we need to do is we'll close out this PuttyGen, and we're going to open up the regular Putty device or the Putty application. It keeps opening up on the other window, which is kind of a pain. And now let's go back to our console. And the way to connect to one of these devices, hit this connect button right here. And it's going to give you all the information on how to connect to this device. And so you'll see that the user for this device is Ubuntu, and then, it's going to also give us the IP address, but we can actually confirm the IP address here. The important thing is we know that we need to log in using the user as Ubuntu. So we'll do Ubuntu, and then to specify the IP address, you do @ and then the IP address. So let's copy this IP address, paste it in. Now we have to log in using that PPK file. And to tell Putty to use that, go into this SSH right here. And I know this text is a little small for you guys. I don't know how to make this bigger, unfortunately. So you're just going to have to bear with me. Hit the auth button. And then there's a section that says private key file for authentication. So hit browse and then just find that main dash key PPK file. Hit open again. And once again, this opened up in another window. And it looks like I'm running into some issues. So I'm not sure what happened here. Let me close this out. I'm going to open up my terminal. I should be able to ping 3228.248.252, or maybe not. Well, that's a problem. Oh, wait, no, we didn't allow pings. Let's just make sure this works again. Okay, so that's good. Now, why is it that we cannot reach this device? So let's check our security group. Let's view inbound rules. Oh, look at this, guys. I messed this up. You see, we're allowing port 2, and we don't care about port 2. We want port 22. So let's go back to our Terraform file. Let's see where I messed that up. Here we go. This is where I messed it up. So this should be port 22. If we hit save and then do a Terraform apply, it should apply this on the fly real quick for us. All right, that's been done. Let's just double check here. So we'll go to view inbound rules. Now it says port 22. And let's open up Putty again and just perform the same exact steps. We want to go to Ubuntu, and then copy this IP address. Go to SSH, go to our authentication, browse, find our main key PPK file, hit open. And it should pop up with this security alert. So just hit yes. And at this point, you should be logged in using Putty. So, we're on a Linux machine. You can run any command you want. But, if we want to verify Apache's running, let's just do a system ctl status Apache 2. I spelled that wrong. And so it's running. And so that's how we, connect to one of these boxes on a Windows machine. Let me show you how to do it on a Mac machine. And let me just copy this PEM file to my Mac machine real quick. And so remember, we want the PEM file on a Mac, and on a Windows, we want the PPK. Okay, guys, to connect to our web server or an EC2 instance from a Mac or a Linux machine, steps are going to be identical. The first thing that I want you to do is go to your web browser and just go to AWS and log into your console. Because it actually kind of walks you through it, how to do it step by step. It's actually really easy. So if we go to our EC2 section and go to running instances, go to your web server and then just hit connect. And so these steps are all you have to do. So we have to do chmod 400 and then the name of that PEM file that we downloaded. And that's just going to set the permissions to the correct values. And then we have to connect to it. So the way to connect to it is you go to your command line, you do SSH-I, then the name and location of your PEM file, and then we want to connect to it doing Ubuntu @ and then the IP address. So that's all you have to do. So let's go to our terminal and let's find that PEM file. So I saved it in my downloads folder. And so I've got that main-key-PEM. So we'll do a chmod 400 main-key-PEM. And now to actually connect to the server, we do SSH-I and then the name of the file. So main-key-PEM. And then now we do Ubuntu @ and then we need to get the IP address. So let's go back here. Let's copy the IP address and then paste it in. And then we hit enter and we should get this same warning that we got on the Windows machine. So we'll hit yes. And there you go. You're now connected to the device and you can run any commands. So that's all I wanted to show you guys in this video. Hopefully you learned a lot. I showed you guys how to create a lot of different resources. These are all things that you're going to need to know how to do. And hopefully at this point, you guys should feel relatively comfortable with navigating around Terraform and creating and deleting resources. Definitely go ahead and, once you're done with this project, do a Terraform destroy because we did deploy a lot of things, and I don't want you guys to get any kind of unexpected bills, even though we are in the free here. So just do a Terraform destroy, and then we can just do a dash dash auto prove. But what happened here? Terraform not destroy. But we still have a lot of things to cover when it comes to Terraform. I get a chance to cover variables, or modules or things like that. So there's still a lot to cover with Terraform. I think that's going to wrap it up probably for this video. I'll make some follow-up videos. If there's any topics you guys want me to cover, let me know and I'm happy to do it. Terraform's been something that I really enjoy working with. So if you guys want me to do more Terraform videos, also let me know and I'll be happy to do any videos or any topics that you guys want. In this video, I'm going to go over a few extra Terraform commands that I think are helpful. And if you've already destroyed the project that we created in the last video, go ahead and deploy it again, or at least just deploy a few resources. We need a few resources deployed so that we can actually take a look at the output. And so I've already done that. So I've already run this Terraform config, and so we have several different resources deployed. And the first command that I want to show you guys is Terraform state list. And by the way, guys, if you don't know what commands to run, I always just start off with Terraform and hit enter, and you'll see that the command line will kind of help you, with the different commands that are available. So these are all the options that we have. And so right now I want to focus on the state subcommand. So where is this? I think it's Terraform. Oh, it's down here. So the Terraform state subcommand. So if we do Terraform state and then hit enter, you can see all of the commands that we have at our disposal. So we've got list. This is the main one that I'm concerned with. So if we do a Terraform state list, this is going to list out all of the resources that we have state for. So any resource that I've created in my topology, we're going to have an entry in this output. And so you can see we have the Elastic IP that I created. We've got the web server that I created, as well as the internet gateway, the network interface, the route table association, the security group, the subnet, and the VPC. And if you actually want to see detail regarding any one of these resources, you can do a Terraform state show and then just copy one of these items. So if I want to see detailed output for the Elastic IP, I can copy that and paste it in. Oops, it looks like I didn't copy it. Hold on. Terraform state list. And then just copy that. And sorry, we need Terraform state show. All right, and so you can see it's going to give us a detailed output regarding that state, and it's going to include a lot of information that would normally only be stored in the AWS console. So we can see the IP address, we can see the association ID, we can actually see the actual ID of the resource that gets created in AWS. Then we can see the ID of the instance this Elastic IP is assigned to, as well as the network interface. And we can even see the public IP. And this is super helpful because there's going to be a lot of times when you deploy something and you want to know what the IP address is, especially the public IP. And normally you would have to do it through the AWS console. But, we have this command so that we can just verify it from the command line really quickly without having to log in. And we could do this with, really any one of the resources that we've deployed. So if you want to see more detail regarding the web server that we deployed, we can copy this and just take a look at that and just do a Terraform state show. And you're going to see all the information that we have regarding that server that we deployed. So we can see the ID, we can see, the AMI that was used, what availability zone it was deployed on. We can see its public IP here as well. And a couple of other details that would once again normally only be available in the AWS console. So, those are the two commands. Keep those in mind. So remember Terraform state list and then Terraform state show. Those are going to be the two big ones. In the last video, I showed you guys how to verify the state information for resources that we've deployed using the Terraform state show command and the Terraform state list command. And those will allow you to see information like the resource ID. It'll allow us to see information about, like what's the public and private IP of a EC2 instance. So we can see a lot of detail about these resources that we've deployed ourselves, and it's super helpful, super handy. But I want to show you another thing that we can do to actually see that information, right? Because after you deploy something, we can always do a Terraform state list, and then whoops, Terraform state list. And so if we wanted to extract the public IP of the Elastic IP that we created, we can always do a Terraform state show, and then just copy that. And you can see here that we can actually see the public IP under the public IP property of this resource that we created. But there's going to be times where, it's kind of a little inconvenient to have to always do a Terraform state list and then Terraform state show for all of the details that we want. What if we could get Terraform to automatically print that out when we run a Terraform apply? And well, guys, there is a way to do that, and that's by using the Terraform output command. So any one of these properties that we can see by doing a Terraform state show on any one of these resources, we can tell Terraform to automatically print those out when the resources are created. And we can do that using the Terraform output command. I'm going to show you just how simple it is. So as I said before, one of the main use cases is extracting the public IP that's going to get assigned to an Elastic IP or a EC2 instance that gets created. So we can just do a Terraform. Oops, not Terraform. We could do the output. And then we have to define an output for this. So I'm just going to call this my server underscore public underscore IP. And then here we just assign it a value. So we get the value from this right here, from this Terraform state show. So to get the value, what we have to do is we have to pass in the name of our resource, which is AWS underscore EIP underscore or .1, and then we want to grab the public IP property. Okay. And so we can go down here and we just say value equals AWS underscore EIP .1 .public underscore IP. Okay. And so that'll get this property and it'll print it out into the console when we run Terraform apply. So let me save this and we'll do a Terraform apply and then -- auto approve. And let's just wait for that to run. And I want you to notice what happens at the end. Right, look at that. So the output that we created, it's going to print out our server public IP so that we don't have to go into the Terraform state and verify it ourselves. And so this can come in handy because, we can print out all the details that we are concerned with without having to actually go in and check the states ourselves. And we could obviously, grab any other property. So as an example, let's say, let's see what other properties we can grab that I think would be cool. Let's do Terraform state list and then Terraform state show. And then let's check our web server instance. So let's say we want to grab the private IP of our server as well as the AMI that's being used. Or no, I think the ID would be cool because we're hard coding the AMI, so who really cares about that? We already know what it is. And so we can just define another Terraform output. So we'll do output. Then we have to give it a name. So just give it any name you want. I'm just going to say server. We'll call this, I don't know, server private IP. And then we're going to do value. And then remember, we have to set this equal to our resource. So we'll copy our resource name. And remember, we need to get our property name. So this is going to be called private underscore IP. And I can't remember if we can put 2 values in here, but let's just give that a shot. And so let's see if I just copy this. And let's print out the ID. And let's try a Terraform apply again. Yep, so it looks like we can only set it once. So we'll have to create another output. And we'll call this server ID. And I'm just going to move this down here. All right. So now when we do a Terraform apply, we should see 3 different output. And there you go, guys. So you can see the 3 different outputs that we've defined. We've got the server ID, we've got the private IP, as well as the public IP. And you can always verify the outputs by doing a Terraform output, and it's going to print out all the outputs for us. However, if you decide to add another output, into your config, but you don't want to do a Terraform apply because technically Terraform apply could potentially make changes to your network. And if you're in a production network, you don't want to accidentally deploy or delete something just to see what the output is. So, if you're in that situation, you can always do a Terraform refresh. And this should, just refresh all of your state and it'll run the outputs again so that you can verify them without actually, deploying anything or doing an actual apply. With the declarative nature of Terraform, it's kind of an all or nothing situation when you want to deploy your Terraform config or destroy it. So you can either spin up everything that's been configured in your Terraform file or destroy all of it. However, Terraform does understand that, there's going to be instances where you want to just delete an individual resource, or if you're just trying to roll out with the deployment to do staged deployments where only certain resources are deployed one day, and then the next day another set of resources are deployed. And so we can target individual resources within our configs to either apply or destroy them by passing in the -target flag. And so I've got a whole bunch of resources deployed, and let's say that I just want to delete this web server right here. Well, we can do a Terraform destroy, and then we can pass the -target flag, and then I'm just going to provide the name of the resource. So we'll do AWS _instance .web server instance. And so this should leave everything else in my configs untouched. So all of these, the route tables, the subnets, all of that should remain untouched. And Terraform should just delete this one EC2 instance. So let's give that a shot and let's see what happens. All right. And so if we go up here just to see what's going to change, you can see that we're going to be destroying just one resource, and that's that web server that we targeted. And so you can see here, only one resource is going to get destroyed. So if I hit yes, it should then delete just that server. All right, so it successfully destroyed just that one resource. And if we want to do the exact opposite thing and deploy just this one resource, we can use the -target flag once again to accomplish that. Terraform apply, on -target, then the name of the resource that we want to deploy. So in this case, we're just deploying just that web server that we just deleted. And I'm going to move the apply to here. All right. And if we take a look at the summary of the changes that'll take place, we can see that it's going to add one resource, which is exactly what we want. We'll hit yes, and let's just double check that everything works okay. And there you have it, guys. We've deployed just one individual resource from our Terraform config. All right, so this was just a short video. I just wanted to make sure that you guys understood how to target an individual resource or individual resources if you want to deploy just a couple. And so that just hopefully gives you a little bit more flexibility on maintaining your infrastructure using Terraform. Now, just like any other programming language, Terraform does allow us to make use of variables so that we can reuse values throughout our code without having to repeat ourselves. And right now, inside this example configuration file, I've got just a VPC being defined. So we're going to create a VPC, and then we're going to create a subnet within that VPC. So nothing new up to this point. You guys should already be familiar with how to do this. But what I want to do is I want to take this CIDR block definition for subnet 1 and store this value right here, the 10.0.1.0/24 subnet, in a variable. And to define a variable in Terraform, it's very easy. All you have to do is just type in variable and then the name of the variable. So we can give it any other name. I'm just going to call this subnet underscore prefix. Okay. And within this variable definition, we can pass in three arguments or three parameters. And all three of them are completely optional. So we can technically leave this empty. But the three options are we can give it a description. We can also give it a default value as well as a type. Okay. And so once again, all three of these are optional, but a description is exactly what it sounds. You can just give it a description. So we'll just say this is going to represent the CIDR block for the subnet. The default value. So the default value is just going to be what Terraform is going to give this variable if we don't actually pass in a value for this variable. So I'm going to leave this blank for now and just comment that out. We don't need it. And then the type. So we can actually perform type constraints on variables so that when a user enters in a value, we can make sure that they enter in the proper type for this variable. So if we're expecting a string, we can say type equals string. And there's a couple of different types that Terraform supports. So, it supports strings, it supports numbers, booleans, lists, maps, sets, objects, tuples. And if you're not sure what type you're going to use, and if you're not really sure what type needs to be passed in, you can always just pass in the any argument to say that we support any type. But, we can just leave this blank for now and we'll come back to using type constraints. So for now, all we're going to do is just provide a description. And I'm going to hit save, and let's see what happens when we actually run our code now. Well, actually, one more thing. We actually have to, use that variable someplace, right? So to actually reference a variable in our code is very simple. So I'm going to delete this subnet right here. And to reference a variable, we just type in var and then dot and then the name of the variable. So that's going to be subnet underscore prefix. All right. And so you can see that nowhere in our code so far have we actually defined a value for subnet prefix. We just provided a description. So if we do a Terraform apply, let's see what happens. And look at that. So any variable that isn't assigned a value, Terraform will actually prompt the user to enter in a value for that. So I'm going to give this a value of 10.0.1.0/24. And so this value that I'm passing in is going to get assigned to subnet prefix. And so once the AWS subnet resource runs, it's going to pull that value and store it for the CIDR block. So let's hit enter. Let's wait for that to run. Okay, so the resource has been added. Let's take a look at the AWS console just to see if that actually worked. So I'm going to go to this prod subnet. And so you can see here that it got passed in a 10.0.1.0/24 prefix. And so that just confirms that our variable is working. Now, it's kind of a pain to have to get prompted for what the value of a variable should be. So there's other ways of passing in values or assigning values to a variable. And one of those is through a command line argument. And so what we can do is I can do a Terraform. Well, first, let's do a Terraform destroy. So we can delete those resources. And it looks like I spelled something wrong. Yep, destroy. And you'll see that when it needs to get destroyed, it's going to ask you for a value for that that variable that we defined. But for destroying, it doesn't actually matter. So you can just technically just leave it blank and it should be able to destroy things just fine. We only really care about passing in the proper value when we're doing an apply. All right, so we've destroyed the resources. Now let me show you guys how to assign a value to a variable through a command line argument. So if we're going to do a Terraform apply, we can also do a -var and then set a value for a variable. So we're going to reference this subnet underscore prefix variable. So we'll do subnet underscore prefix. And then we can set it to whatever value we want. So I'm going to do the 10.0. Let's do 100.0/24. We'll hit yes. And now let's double check in the console to make sure that this new value got assigned. And so you can see here, we've now got our 10.0.100.0. So the variable assignment that got assigned on the command line argument worked. Now this is cool and all, but in reality, I don't think we're going to use either one of these methods to assign variables very often. The best way to do it is actually creating a separate file to assign variables. And Terraform automatically looks for a file called terraform.tfvars for variable assignments. So we can just create that file now, and we'll do terraform.tfvars. And here we can define a value for that variable. So I'm going to go back, what was it called? Subnet prefix. And so we'll do subnet underscore prefix equals, and then let's give it the value that we want. So we'll do 10.0.200.0 just to show that something has changed. And so I'm going to do an apply without passing in an argument. And it looks like it's still asking for assignments. So let me cancel that. I messed something up. I forgot to hit save probably. Yep. Oh, let's just wait for that to finish. Okay, I canceled out of it. So hit save all. And so now, because we've actually defined this variable here, it should not prompt us for a value for that variable. Okay, and so let's hit refresh and let's take a look at the value. And so now it's set to the 10.0.200.0/24. So those are really the three different methods for assigning variables. Technically, we can also use environment variables from your operating system. I'm going to hold off on using that as an example or giving you an example of how to do that because that's going to come into play when we worry about how we're going to store our credentials for Terraform instead of just hard coding it into our Terraform file. So in that scenario, it's really good to use environment variables. So I'm going to hold off on doing a demo of that for now. Now, the next thing I want to cover is, well, first of all, let's say that we didn't want to use a file called terraform.tfvars. Let's say we wanted to call it something else. Or let's say we had multiple files for multiple variables, which is very common, especially when your Terraform config starts to grow. You don't want to store everything in just one file. Well, we can tell Terraform to actually look for a specific file name. So if I rename this, actually, before I do that, I'm going to do a Terraform destroy. All right, and so now I'm going to rename this. I'm going to rename this to, let's just say, example.tfvars. Okay. And now for Terraform to actually look for that file, we have to explicitly tell it to look for that file. And we can do that by passing in a simple flag. So I'm going to do Terraform apply. And we can pass in the flag -var-file. And then we give it the name of the file. So we'll do example.tfvars. And so you can see that we didn't get prompted to enter a value for that variable because Terraform was able to look at this example.tfvars file and find this value. Now, in the earlier parts of this video, I did mention that one of the options to pass into a variable assignment is a default value. And so this default value can be used if the user doesn't input a specific value. And we can do an example of that just by deleting this right here. We'll save that file and let's just assign a default value. So we'll say default equals 10.0.66.0/24. So if the user doesn't input a variable assignment, then Terraform will automatically assign this variable this value. So once we save that, we can then do a Terraform apply. And there you go. So even without having a value assigned to that variable, you can see that it still ran. And if we go to the to AWS console, take a look at that, you can see it got assigned a value of 10.0.66.0. So this is a way to apply a default value for a variable. I'm going to remove this for now just so I can do a few more demonstrations using variables within Terraform. I'm also going to rename this so I don't have to keep passing in a input argument. Now I'm going to show you guys how to actually perform a type constraint on a variable. So in this case, the subnet or the CIDR block needs to be a string that holds the value of our subnet. And so we don't want to receive a variable of any other type other than a string. And so what we can do is we can say type equals string. And so now if I go to my terraform.tf and do a subnet underscore prefix equals, and instead of assigning 10.0 to 0 slash 24 or something as a string, let's say I try to put in a list and I try to assign this value. Right? Let's see what happens now when we try to run that. Whoops, it looks like string is not a valid type specification, so it must be a lowercase s. See, and so now it throws an error saying the given value is not valid for a variable subnet prefix, because it checks to see if it's a string and it sees that it's not a string, so it throws an error. So this is just another way to make sure that especially when you're working on large code bases and you're sharing your code with colleagues, this will just make sure that your colleagues don't accidentally input a wrong variable type into a variable and then potentially see an error when they run the config. So it's just another sanity check that you can do. Now, while this is set to a list, I want to show you guys how to actually use a list as a variable. And so what I'm going to do is I've removed that type constraint and I'm going to create a second subnet. And I'm just going to call this, we'll just call this a dev subnet. And we'll call this subnet 2. And here we're going to specify the CIDR block for both of those subnets. So I'll do 10.0.1.0. And then for the second one, we can pass in a value of 10.0.2.0/24. We've got a list. And now to reference the list, all we have to do is just change this up a bit. So this is going to be the first object in that list. So when you're working with lists, the first object can be referenced with a 0. Then the second one will be referenced with a value of 1 and so on. So it's just like any other programming language. Set that to 1 and let's give this a shot and see if it works. And so now we've got our two different subnets. The prod subnet should be a 10.0.1.0 and the dev subnet should be a 10.0.2.0. All right, and there's one more thing I want to show you guys with variables, and I want to show you how to use objects within variables. So right now we just have a list of strings, but we can also have a list of objects too. And so what I'm going to do is I'm going to change up the way I assign the tag. So instead of assigning, the tag or hard coding it, what I want to do is I want to have a variable that's going to look like this, where we're going to have an object and we'll have two properties. We'll have the CIDR block, and then we'll also have a name property. And so that way the CIDR block will get assigned to the CIDR block and the name will get assigned to the name. And so we'll remove that. We'll go back to our Terraform TFRs file and let's see how we can actually do that. So here we'll create an object and we'll assign it a CIDR underscore block should equal, and that's going to be the 10.0.1.0/24. And then then we have to specify a name. So we'll just give it a name. And this is going to be prod underscore subnet. And then that's going to be for subnet 1. And then for subnet 2, we'll do the same thing. So we'll assign a property of CIDR underscore block, and we'll set that equal to 10.0.2.0/24. And then the second property is going to be the name, and that's going to be set to dev underscore subnet. And so we're going to have to update a few things here. And so under the CIDR block, we want to grab the CIDR block property. And now for the name, we're going to have to reference that variable. And we'll do a var dot subnet prefix. We want to grab the first item. And we'll do dot name. And we'll copy this and just paste it down here. Just make sure to update it so it's the second object. Yep, and there you have it, guys. We were able to now use a variable, which is a list of objects, to assign values within our Terraform configuration file. So there's a lot of flexibility with variables. You definitely want to make use of them for as much as possible so that you're not retyping the same thing over and over across large configs. And so just keep in mind, it was a little confusing at first for me, especially because we have to, define the variable, but we don't assign it here. We have to assign it in the tfvars file. So just keep that in mind. In the tf files, you define a variable, and then tfvars, you actually assign it a value.